If the Earth suddenly stopped spinning, what would happen next? Earth feels still beneath our feet, but that feeling is an illusion. Our planet is rotating all the time, and at the equator, the surface is moving eastward at more than 1,000 miles per hour, or about 1,600 kilometers per hour. That speed drops with latitude and becomes effectively zero at the poles. But everywhere except the poles, the ground, the atmosphere, and the oceans are all participating in the same planetary spin. It is the rotation that gives Earth the familiar rhythm of sunrise and sunset and helps shape the global behavior of air and water. So, what would happen if Earth suddenly stopped rotating? To answer that honestly, we need to separate two different scenarios. The first is the cinematic one. The solid Earth stops almost instantly, while the atmosphere and oceans keep moving with the momentum they already had. The second is the slower, more abstract version. Everything stops together and the planet settles into a new equilibrium. The first is immediate catastrophe. The second is a long, strange remarking of climate and geography. In the video, we begin with the violent version because that is what most people imagine when they ask the question. It is also the version most likely to destroy life on a global scale. The reason is simple physics, inertia. If the crowd stopped but you did not, you would keep moving east at the speed you had a fraction of a second before. Near the equator, that means more than 1,600 kilometers per hour relative to the now stationary surface. Buildings, forests, vehicles lose sorrow, and entire layers of infrastructure would be thrown violently eastward. People would not merely lose balance, they would become projectiles. Even far from the equator, where rotational speed is lower, the effect would still be catastrophic. Only near the poles would the direct horizontal velocity from rotation be relatively small. This is not because the poles are safe in any broader sense, but because rotational speed there is already close to zero. The same would be true for the air. Earth's atmosphere rotates with the planet, and if the surface stopped suddenly while the air kept moving, the planet would be hit by extraordinary winds moving from west to east. The exact speed would vary with latitude and terrain. But the broad outcome is clear by inference from Earth's rotational velocity and the way the atmosphere normally shares that motion. Much of the world would experience supersonic or near supersonic devastation, especially in low latitudes. The atmosphere would not politely catch up. It would continue moving, smashing coastlines, flattening structures, and filling the air with deep debris, water, dust, and fire. That inference is grounded in the fact that Earth's surface velocity is rotation dependent and greatest at the equator. This is the first major correction to the popular imagination. People often picture the sun freezing in place overhead, as though the main consequence would be permanent day on one side and permanent night on the other. That would matter later. But first comes motion, sudden stopping as not merely a lighting problem, as an inertia problem. A planet that has spent billions of years rotating does not simply pause without everything not rigidly locked to the crust trying to keep going. There is another subtle point here. The Earth is not a perfect sphere because of rotation. It budges slightly at the equator. NASA explained that forces associated with Earth's rotation make the planet slightly oblate with an equatorial part. That means rotation is not just something Earth does as part of the shape it has settled into. Remove rotation, and eventually even the planet's distribution of water would begin to adjust to a different balance of forces. But that comes later. In the opening moments, shape is not the story, survival is. So the first seconds after a sudden stop would not feel like silence or stillness. They would feel like the end of the world delivered sideways. Ground, air, and ocean would no longer agree on how fast they were moving. The result would be impact, friction, heat, destruction, and a global chain of disasters beginning almost instantly. And the worst of it would not be limited to land, because the oceans too would try to keep moving. If the atmosphere became a weapon in the first moments after Earth stopped spinning, the oceans would become the second. Water has mass, momentum, and almost no patience for sudden interruption. The seas rotate with the planet just as the air does. And if the solid Earth stopped abruptly, the oceans would continue shifting eastward by interference from Earth's rotational speed, and the fact that ocean circulation and sea level are shaped partly by Earth's rotation. Coastlines would be hit by unimaginably violent water movement. It would not be a normal tsunami caused by an earthquake under one section or of seafloor. It will be a planet-wide rearrangement of moving water slumping into continental margins, pouring across lowlands, and shredding ports, islands, and coastal cities. A conventional tsunami is terrible precisely because it delivers huge masses of water with little warning. Now imagine something broader, entire ocean basins retaining eastward momentum while the ground beneath them no longer shares it. In the early phase, was the water surged across coastlines, ships would be thrown inland or broken apart. Harbors would vanish, shelter regions and flood coasts would be obliterated. The world's most densely populated urban belts, many of them coastal, would face destruction almost immediately. The outcome is an inference from inertia and the role of rotation in the behavior of large Earth systems, not a direct observation, Because fortunately, no such planetary event has ever occurred, but the underlying mechanics are straightforward. Then comes the longer response, because Earth's current shape includes an equatorial belt. Sea level is not distributed as it would be on a non-rotating planet. NASA knows that the Moon and Sun act on Earth's equatorial belt, and that rotation is part of why Earth is slightly oblate rather than perfectly spherical. If rotation vanished for good, that belt would no longer be supported in the same way. Over time, by inference, ocean water would tend to migrate away from the equatorial regions and redistribute toward higher latitudes under the new balance of gravity and shape. That means some equatorial coastlines could eventually lose water, while polar and subpolar regions gained enormous new seas. They all create a world map almost impossible to recognize. Parts of the equatorial ocean floor might emerge at dry land over geologic or at least long physical adjustment timescales, while high latitude regions could drown under redistributed water. The exact geometry would depend on how quickly the stop happened, how the mantle and crust responded, and how water settled into the new gravi- gravitational equilibrium. But the principle matters more than the precision here. Today's coastlines are partly a product of a rotating Earth. Change the rotation, and eventually you change the coastlines. Even before that redistribution stabilized, the ocean atmosphere system would remain in chaos. And OAA notes that circulation mixes water in the oceans and transports water vapor through the atmosphere. A sudden interruption to rotation would not gently simplify that system overnight. It would shatter existing current patterns, radically alter evaporation and rainfall zones, and likely produce years of unstable, violent transition before any new pattern emerged. The modern climate is not just about sunlight, it's about movement of air, water, heat, and moisture. Rotation is one of the major organizing rules behind that movement. So, if the first part of this scenario is impact, the second is flooding. The sea would not merely rise in one place and fall in another, it would attack, retreat, relocate, and redraw the planet. Coastlines that have existed for human civilization would disappear. New inland seas could form, weather would lose its familiar map, and all of this would unfold while the atmosphere was still in violent disequilibrium. People sometimes talk about Earth stopping as if it were a single event. It is not, as Earth cascade. And after wind and water, the next transformation would be written in light itself, because a non-rotating Earth would experience time very differently from the one we know. Now imagine that the immediate chaos has passed, not because life is stable again, but because the first impacts, winds, and ocean surges have already done their work. the planet has stopped rotating, that it still orbits the sun. What happens to day and night? If Earth stopped spinning on its axis but continued moving around the sun, the familiar 24-hour cycle would disappear. Day and night, as we normally experience them, exist because the Earth rotates once roughly every 24 hours relative to the Sun. Or they exist because Earth orbits the Sun. If the rotation vanished while the orbit remained, then the Sun would no longer appear to rise and set daily. Instead, the position of the Sun in the sky would change over the course of Earth's early daily trip around the Sun. In effect, the solar day would become comparable to one day long. There is a direct inference from the basic relationship between rotation, orbit, and the solar day, and it is conceptually similar to synchronous or tidally locked behavior described by NASA for many moons and some planets. That means one side of Earth would spend months heating under continuous sunlight, while the other endure months of darkness. But contrary to the simplest movie version, there would not be one permanently fixed day side and one permanently fixed night side, unless Earth also became tidally locked to the Sun in a more specific long-term sense. In the immediate hypothetical where rotation stops but the orbit continues, the point beneath the Sun would migrate over the course of the year. So instead of daily sunrise and sunset, most places would experience extremely long seasons of daylight followed by extremely long seasons of darkness. The consequences for temperature would be severe. During prolonged daylight, land surfaces would heat relentlessly. During prolonged darkness, they would cool thus relentlessly. Oceans and atmosphere would moderate some of the most extreme contrasts by transporting heat, but NOAA's guidance on non-rotating atmospheric circulation makes clear that without Earth's rotation, the entire global flow pattern would simplify dramatically, with air moving in more direct paths between warm and cold regions. That means heat redistribution would still exist, but under radically different and likely more violent circulation rhythm than the one modern civilization evolved within. They would transform agriculture almost beyond recognition. Most crops are adapted not just to temperature, but to rhythmic cycles of light and darkness. Photosynthesis, flowering, pollination, dew formation, soil temperature, and seasonal timing all depend on patterns that would be started by months-long exposure and months-long darkness. Forests in some regions would burn or desiccate during extended day. In others, long freezes and light deprivation would kill vegetation during prolonged night. Some ecosystems might persist near twilight transition zones where heating and cooling were less extreme. but the current distribution of light would be devastated. That conclusion is an inference from the known importance of sunlight, temperature, and atmospheric moisture transport to ecosystem function. Human society would face the same problem on a civilizational scale. Energy demand would explode. Water infrastructure would fail in some places and become useless in others. Cities designed for predictable weather and a daily thermal would not cope well with months of instant heating, followed by months of darkness and cold. Migration toward more survival latitudes or toward moving taller belts would become one of the defining pressures on any survivors. In practical terms, the concept of local climate would have to be reinvented. And that this still is not the full story, because light alone does not determine climate. The way air moves across the globe matters just as much. On our rotating Earth, the Coriolis effect bends, winds, and helps create the major circulation cells that steer storms and ocean currents. NOAA notes clearly that without Earth's rotation, the atmosphere would circulate in a much simpler back and forth pattern between the equator and the poles. Simple does not mean gentle, it means fundamentally different. So, after the first physical catastrophe and the first lightning shock, the third transformation would be at atmospheric. The skies themselves learn a new geometry. The atmosphere on the modern Earth is shaped by rotation so thoroughly that it is hard to imagine weather without it. Trade winds, jet streams, storm tracks, the broad organization of circulation cells, they are all tied to the fact that Earth spins. NOAA explains that the Coriolis effect exists because Earth rotates and that without rotation, atmospheric circulation would tend toward a simpler pattern between the equator and the poles rather than the curved multi-cell system we know now. That sounds almost peaceful at first. Simpler circulation, fewer twists, perhaps a calmer atmosphere, but simpler in planetary physics do not mean safer. On a non-rotating Earth, the major driver would be a direct thermal construct. Regions under prolonged sunlight would heat intensely, air would rise there, and colder air from darker or high latitude regions would flow toward the heat source to replace it. NOAA's non-rotating model shows warm air rising near the equator and cold air sinking near the poles in a single cell pattern when rotation is absent. In our hypothetical, because the hottest zone would migrate with Earth's orbit relative to the Sun, the pressure system would not be static. They would evolve over long time scales, dragging weather with them. The result would likely be immense pressure gradients and broad, relentless winds rather than the familiar choreography of rotating storms and jet streams. Today, the Coriolis effect bends motion and helps organize weather into spirals, tracks, and belts. Remove that effect, and air no longer curves the same way. It moves more directly from temperature driven high pressure zones toward low pressure zones. That may sound more straightforward, but the energy involved could be enormous because the heating contrast on a non rotating Earth would be enormous. Hot air would rise aggressively in sun-baked regions; cold, dense air would plunge and flow from dark or polar sectors. The atmosphere would still transport heat, but through a planetary engine with a different architecture. Oceans would also change fundamentally. NOAA notes that the deflection of the atmosphere by Earth's rotation has destroyed the complex global wind patterns that in turn drive surface ocean currents. USGS similarly explained that circulation mixes water in the oceans and transports water vapor in the atmosphere as part of the water cycle. If rotation vanished, the current system that today redistributes, such as the guides and associated circulation patterns, would be disrupted or rebuilt into something else entirely. That means coastlines would not just face new sea levels, they would face different motor pathways, altered rainfall, and different temperature moderation from nearby seas. Rainfall zones would shift dramatically. Regions that today depend on steady seasonal circulation could become deserts. Areas now dry might receive persistent storms, monsoons, subtropical dry belts, and storm corridors are not accidental features painted onto the Earth at random. They emerge from rotation, solar heating, water distribution, and land-sea construct acting together. Remove one of those structural forces and the whole climate map must be redrawn. This is why a non-rotating Earth would not simply be hot on one side and cold on the other. It would be a moving climate emergency with new wind systems, new water pathways, and new habitability zones. Some regions might become survivable not because they were made in absolute terms, but because they sat near the long twilight margins between severe heating and severe cooling. Those zones could become the most desirable real estate on the planet, not because they were comfortable, but because everyone else was. The twilight zone habitability is partly an inference, but is grounded in NOAA's non-rotating circulation models and broader climate logic about heat redistribution. And that leads to an important correction. A world without rotation would be alien, but not necessarily dead in every region. Air and water would still move, heat would still spread, the sun would still power weather. The problem is that the rhythm, balance, and geography of survivability would be profoundly altered. Civilization built on coastlines, seasons, and predictable atmospheric patterns would not be living on the same practical planet anymore. But there is one more misconception that needs clearing up. Stopping Earth's rotation or change a great deal. It not change everything people think. One of the first myths people read for in this scenario is that gravity would vanish or become too weak to hold Earth down. That is not what would happen. Gravity is produced by Earth's mass, not by its daily rotation. Rotation slightly reduces effective gravity at the equator because of centrifugal effects, and NASA knows that the reduction is not all is only about 1/3 of 1%. So if Earth stopped spinning, you would weigh a tiny bit more at the equator than you do now. But gravity itself would still be very much present. The real problem would not be floating away, it would be everything else. Another common myth is that Earth would instantly lose its magnetic field. That too is oversimplified. NASA explains that Earth's intrinsic magnetic field is generated and maintained by convective flow in the fluid outer core. A geodynamo, the magnetosphere, in turn helps protect Earth from harmful solar energy and charged particles. Rotation is relevant to Earth's deep dynamics on long time scales, but the magnetic field is not simply a light switch directly connected to the 24-hour day. In other words, a sudden stop in surface rotation would not mean the magnetosphere vanishes in the same instant. That distinction matters because it shows how a system overlaps without being identical. Rotation shapes weather, ocean currents, and the equatorial belt directly. The geodynamo depends on deep interior fluid motion and heat flow. Those systems are connected in the broad history of the planet, but they do not all respond on the same time scale. In a sudden stop scenario, the atmosphere and oceans would become catastrophic immediately. The magnetic field would not be the first or most urgent disaster for surface life. What about Earth's orbit? People sometimes imagine that stopping rotation would also cause Earth to fall into the Sun, but orbit and rotation are different motions. Earth rotates on its axis and also revolves around the Sun. NASA's own educational materials distinguish clearly between Earth's spin state and its orbital motion, and the existence of tidally locked moons in the solar system shows that an object can have one rotational relationship while still continuing its larger orbital path. So in the hypothetical, Earth could stop spinning and still continue orbiting the Sun, at least in the simplified thought the experiment we are exploring. Tides would remain as well, because tides are driven primarily by the gravitational pull of the moon and to a lesser degree the sun. NOAA explained that Earth's tidal patterns are aligned with the positions of the moon and sun. Rotation strongly affects how tides are experienced in time and location, but the gravitational source of tides would still exist. In practice, tidal behavior on a non-rotating or a roughly stopped Earth would become much stranger because coastlines, oceans, and planetary geometry would be changing, but it would not simply disappear. So here is the cleaner scientific picture. If Earth suddenly stopped spinning, the biggest near-term killers would be inertia, wind, quarter movement, climate disruption, and civilizational collapse, not zero gravity. Instant magnetic death or immediate orbital failure, though dramatic, may survive because they sound comics. The real answer is more physical and in many ways more terrifying. It is not one giant fantasy effect, it's a chain of scientifically grounded consequences emerging from momentum, atmospheric circulation, ocean behavior, and energy balance. This is why what if Earth stopped spinning? It's such a powerful thought experiment as it poses how many normal features of life are built on planetary rotation without us noticing. The shape of the planet, the path of the winds, the movement of the oceans, the timing of day and night, the map of climate, the agricultural calendar, the architecture of weather, rotation as background infrastructure for the entire biosphere. We ignore it only because it is constant. And once you see that, the question stops sounding like science fiction. It starts sounding like a lesson in how delicately our normal world is assembled. At the point, it's worth stepping back and asking a deeper question. Why is this scenario so destructive? Why does stop being one motion create consequences across weather, water, geography, and survival? Because Earth is not a collection of separate systems, it's a coupled machine. NASA's Earth rotation materials note that even real-world events such as major earthquakes can slightly alter Earth's spin by redistributing mass. NASA Earth data explains that when tectonic plates shift mass toward or away from Earth's axis, the laws of physics require small changes in spin that may sound unrelated to our imaginary catastrophe, but it reveals something fundamental. Earth's rotation, mass distribution, and physical systems are all linked. Rotation is not a cosmetic feature painted on top of the planet. It's impacted in how the planet behaves. The same is true in the atmosphere. NOAA describes global circulation as the movement of air around the planet that explains how thermal energy and storm systems move over Earth's surface. Without Earth's rotation, that circulation would be radically simpler in structure, which means radically different in effect. Meanwhile, USGS emphasized that circulation mixes ocean water and transport water vapor through the atmosphere as part of the water cycle. They are not side systems. Their life support infrastructure, change dam and nutrient rainfall, agriculture, storm behavior, evaporation, and habitability. Even the shape of Earth carries rotational memory. NASA's discussion of the equatorial belt makes that clear. The planet is not perfectly spherical because spinning bodies do not settle into the same shape as non-spinning ones. So stopped Earth would not merely experience new weather, it would be a different physical planet settling toward a different long-term equilibrium, sea level, coastlines, and pressure patterns would eventually answer to a different geometry.